All right, guys, so we are continuing our learning of quadratics. So you are going to be on 5-2. You're picking up with the bell ringer at the top. So I want you to read through that bell ringer, look at the profit graph, and answer those 3 questions down below. So again, read through the bell ringer paragraph and then answer the questions down below. Yeah, but it should have had the bell ringer page. Right, so we are looking at a profit function. A profit function is an example of how a quadratic function might be used in the real world. So it says Ariel works in the marketing department of a retailer. Her job is to set prices for new products sold in stores. She wants to determine that the certain products for her store meet a profit, and she wants to determine the price range by finding the prices for which the profit is equal to 0. And we can also look at when is the profit a maximum. So we are picking the zeros because, again, the title of this unit is Solving Quadratics. We solve quadratics by setting them equal to 0 or finding the zeros of that quadratic. So in this case, the zeros were relatively easy. They were right there on that graph for you. But prior to asking you that, I ask you 3 other questions. So let's go over the answers to those 3 questions. So the first is, what direction is this parabola open? The answer is down. We know it's open down because the A value is negative. A negative A value tells me the graph is open down. The H value, or the value at which the maximum occurs, was 16. The H value, or the value the maximum occurs, is 16. And then the values or profits that make this 0 were 12 and 20. You could have pulled that from the graph, but you can also check it because in that description, we were given the equation. So what you could do is pick the values you got in the graph, and you can check them by actually plugging in 12 or 20 to see if it is 0. Okay. Example 4, we have 10x equals negative 25 minus x squared. So once again, in order to find all of our key pieces of information, what we need to do is to solve this equation for x squared. So in order to find our key pieces of information, we need to solve for x squared. So I'm going to add x squared to the other side plus 10x. I'm also going to add over. So I added x squared, I left the 10x, I'm going to add the 25, and that would leave this set equal to 0. I moved the x squared and the 25 to make my x squared value positive. You could have moved it the other direction, but it would allow you or show you a pulling out of a negative anyways. So I simply moved it to the left to make it positive. It says find the y-intercept. The y-intercept is the c value in standard form. So my y-intercept is 0, 25. Find the equation of the axis of symmetry. Well, that's x equals h, where h is negative b, so negative 10, divided by 2a, so 1. Negative 10 divided by 2 is negative 5. So that tells me that this graph is symmetric through negative 5. And then our vertex is h, comma k. So I have to find my k value by plugging h in. So that's negative 5 squared plus 10 times negative 5 plus 25. So negative 5 squared is 25 minus 50 plus 25. So 25 plus 25 is 50. 50 minus 50 is 0. So that gives a vertex of negative 5, 0. That's the first point in my table. And then I can find my remaining points by taking that idea of 0 minus h, and then it goes to 1 minus 5, which is negative 4, 2 minus 5, which is negative 3, 3 minus 5, which is negative 2, and 4 minus 5, which is negative 1. And then you do your YA plus K. So that's 1 times 1 plus 0. So that's 1. Then that's 4 times 1 plus 0, or 4. 0, 1, 4. Then it goes 9, and then 16. Each one is multiplied by 1 in this case, and adding 0. So we get all of the perfect squares, 0, 1, 4, 9, 16. That's my Y-intercept is also that perfect square of 25. And again, we know that if the blue dot is 3 to the right of the axis of symmetry, it has a matching counterpoint to the left. And there is my graph. The roots are where it hits the x-axis. So the roots are where it hits this line right here. So in this case, my root is actually my vertex, which is negative 5, 0. So in this case, my root is my vertex, and it is negative 5, 0. So not every absolute value or quadratic has what we call nice roots. And that's part of the reason I taught you guys that graphing table with the YA plus K and the X plus H. So the reason I use that table is because it will always give you very nice points to graph. What happens is if sometimes we pick random points or points we like to look at, we can't see that pattern of equality, or we can't see that pattern of a nicely plotted graph. So here we're given a table, and you have like negative 3, 12, negative 2, 3, negative 1, negative 6, 0, negative 2, 1, 4, 2, 8, 3, 14. looking at that table, can you really see the vertex? No, because you don't see a pattern of symmetry. But yet we're told that these points represent a quadratic. So I teach you that YA plus K table just because it will help you see that symmetric, nice parabola. If you just plug in random points, you might have a table that looks like this. And then when you plot it, you don't see that symmetry. Not that it's wrong, it's just that it's harder to see. So oftentimes roots are not found as perfect whole numbers. Oftentimes roots are not found as perfect whole numbers. So what we need to do is look at a table and estimate where those roots might be. So we can look at a table and estimate where the roots might be. So when you have the value of a function, if it changes on y from a positive to a negative, in order to go from a positive number to a negative number, we have to also go through 0. So what I know is somewhere between -2 and -1, this graph has to cross at 0. I know this because the only way for y value to go to a positive to a negative is to always pass 0. So the other option, or the reverse of that, is going from a negative to a positive. If a value goes from a negative to a positive, it also has to cross through 0. So it says oftentimes exact roots cannot be found by graphing. You can estimate the solutions by stating the integers between which the roots are located. So when the function is positive and then negative, we know there is a 0, and when it is negative and then positive, we know there is a 0. So in this case, it says estimate where the roots are located. So for me, the roots are between x equals -2 and x equals -1, and x equals 0 and x equals 1. If I were to roughly graph these points, I could see that idea. So you have -3, 12. You have -2, 3. You have -1, -6. You have 0, -2. 1, 4. 2, 8. And 3, 14. So again, this graph may not actually be quadratic. It has like a little bit of a curve, but you're looking for the roots. And you could see, and mine's off even a little bit, how these are between those 2 points. Again, my graph is off a little because I sketched it quickly. So let's look at another table of values. This time we are given an equation, so we can find the roots using our given equation by making our table. So we're going to find all of our key points again. So we want to know, okay, what's the y-intercept? So I know on my graph I have the point 0, 4. All right, what's my vertex? So that's the H and the K. So H is negative B, so positive 6 over 2A. So 3, and K is 3 squared minus 6 times 3 plus 4. So 9 plus 4 is 13. 13 minus 18 is negative 5. Okay. So I can already kind of look at those 2 points I plotted and know that somewhere between 0 and 3, I'm going to have a root. So I'm going to make my table the same way I usually make it. Now this time, I'm going to put the vertex in the middle of my table. And then it's 0 plus h, which is 3, 1 plus 3, which is 4, 2 plus 3, which is 5, and 3 plus 3, which is 6. And then you can actually go the opposite direction. So it would be negative 1 plus 3, which is 2, negative 2, and negative 3. So we see that my x values in my table go 0 to 6. And then you can apply your YA plus K. So your Y goes 0, 1, 4, 9. My A is 1. And my K value is negative 5. So 1 times 1 is 1 minus 5 is negative 4. 4 times 1 is 4 minus 5 is negative 1. 9 times 1 is 9 minus 5 is 4. And what's really nice about making the table this way is whatever my Y values are to the left, they are the same to the right. Let's plot our points. So again, what you notice this time is that when I plot my points and I look at my graph, there are no zeros in my table. So I need to look at where does the table go from a negative to a positive or a positive to a negative. And that happens twice. So my roots are between x equals 0 and x equals 1, as well as between x equals 5 and x equals 6. So we can see that both from the graph and the table. So again, it's important to note that not all roots are whole numbers. In the case of this problem, my roots are decimals. If your roots aren't whole numbers, this is an example of a quadratic that is not factorable. So this would be a quadratic that is not factorable. We're going to talk about factoring next week. So your homework is that next page in that packet. It should be roughly problems 14 to 32. In our case, we're doing all of the problems, not just the evens, because I made your worksheet. So again, you're doing that next page in the packet. There should be like a table, etc. Yep. Yep, so it's the front, so it's actually the front, back, and all the way to the third page. It's 3 pages. It has the word problems too. You're stopping where it says 5-2 lesson check, right? The next page says lesson check. Yep, so you're doing, it's 3 pages. I spaced it out just to give you room. So it's some graphs, it's some tables, and then it's a couple word problems.